So now we get to hear from NASA astronaut Kay Hyre. She is joining us this evening. She, after graduation from the U.S. Naval Academy, Kay began her career as a naval flight officer flying airborne oceanographic research missions to 25 countries. In 1993, she became the first female in the U.S. military to be assigned to a combat aircrew. Woohoo! Her NASA career began at the Kennedy Space Center in 1989 as a space shuttle engineer. For 6 years, she processed space shuttles from landing through ground preparations and launch countdowns in support of 40 missions. When she joined the 1995 NASA astronaut class, Kay moved to the Johnson Space Center in Houston, Texas. She became the 34th woman to fly in space when she launched on Space Shuttle mission STS-90 Neurolab. That was a 16-day life sciences space shuttle mission flight aboard Columbia. She also flew a mission on Endeavour to the International Space Station, where she installed Node 3 and the cupola. And I want a show of hands for anyone who knows what Node 3 and the cupola is. All right, Kay, you've got some explaining to do. There's a few people, though. Tonight, astronaut Hyre is going to share her experiences on the International Space Station and discuss the latest research and technologies preparing humans for a journey to Mars. Please help me welcome NASA astronaut Kay Hyre.
Well, good evening. I'm going to use the handheld so I can walk around a little bit more. Thank you all for coming out tonight. Really thrilling to see so many folks here that are interested in going to Mars. And also thank you, Dr. Levine, for reassuring us that humans are needed on Mars, most especially the astronauts. Truly appreciate that. So I'm going to be talking to you about the latest research and technologies that are helping to prepare humans for this journey to Mars. And I can't think of anything more latest than maybe something that just happened like today. Give me a second while I make this work. Here we go. Actually, Sunday morning here on the Virginia coast.
And we have ignition.
Liftoff confirmed. Antares and the SS Gene Cernan now bound for the International Space Station.
So just a quick show of hands, how many people saw the launch? A few folks here. I know it was early in the morning. It was originally scheduled for Saturday morning, and yes, it was cold out there Saturday morning. But this was the Antares rocket carrying the Cygnus cargo module to the International Space Station. It ended up launching on Sunday morning, and it arrived this morning at the International Space Station, where it is delivering about 7,300 pounds of cargo, which includes logistics type supplies, spare parts, clothing, food, but most especially and exciting for us is about 1,900 pounds of scientific experiments that will be used on board the International Space Station. So we're talking about Mars. What does all this have to do with Mars? Well, the journey to Mars, most especially for humans, is going to be very, very challenging. It's a long way, and it's going to take us a long time. So the first challenge we have is, how do we get there? The next one is, how do we land on this planet that we're not quite really used to and don't really know that much about? How do we live and work on this planet? And then how do we have a safe return? Because, oh, by the way, NASA's plan is to safely return our astronauts. Not all those Mars plans out there include that. And then wrap all around that the exponentially greater distance and the longer duration than we have ever experienced in our 56 years of human space exploration. So, how are we going to get there? We mentioned this a little bit earlier. Orion and the Space Launch System, the hardware is being built and being tested. This is happening as we speak. I'm not going to go into a lot of detail on this. I invite you to go online and check this out, and also stay tuned because you will be seeing further test flights of this. And just to throw in another plug for the local area in Virginia, the Langley, NASA Langley Center, just a bit not too far from here, does a good bit with us on the Orion development, especially its return back to Earth. So again, Orion and Space Launch System are something that we are looking at right now, and technology we are developing right now to help us get there. Just to give you a little bit of a scope of this, the International Space Station is about 250 miles up above us. We consider that low Earth orbit. You can actually achieve low Earth orbit in about 8.5 minutes. The moon is about 3 days away at about 250,000 miles. But when we go to Mars, that's going to be about a 6 to 9 month trip. And the reason we give that range is the Earth is moving and Mars is moving. So at different times, they're different distances away. But that Mars trip of 69 months is what it's going to take us to cover roughly about 140 million miles. So we've got a few challenges there to overcome. And we have a concept that we've been developing, and you'll hear more about this a little bit later. But the concept of potentially putting a deep space gateway out in the area of the moon is to get a little further away from the Earth so that we can have more experience operating our systems, developing the technology, and even the procedures that we are going to need as we travel further and further away from our favorite planet. So speaking of the next thing, we said, okay, getting there is going to be hard. What about landing? Well, we've learned a lot from the orbiters that we've sent around Mars, but and even the ones that have landed. This sequence I'm showing here was the tremendously innovative landing sequence that we used for the Curiosity rover. As you see it dropping off its heat shield and then the back shield separated in the way it came down. And that was pretty nifty the way the NASA and the JPL team came up with this. But just something to note, that rover was about 1 metric ton. If we send a human, when we send a human mission to Mars, we're estimating between 20 to 40 metric tons of a lander, because we're going to need that much mass to deal with all of the equipment that we're going to need when we live and work on the surface, as well as that launcher that's eventually going to get us back off of that surface. So again, very, very challenging, and we're working on various ideas at this time. So let's talk about the International Space Station. We said getting there is going to be hard, landing is going to be hard, living and working on the planet is going to be very challenging. But the good news is we've been researching this on the International Space Station for the last 17 years straight. We have had crews 24/7 on board the International Space Station. I think there's a few people in this room that are younger than that even. 24/7, 17 years. We have been conducting science in the most amazing laboratory that has the effect of not even sensing gravity, microgravity of space. So this has given us a great platform to really research this strange and very challenging environment of being in space, and also to develop technology and procedures that we're going to need as we travel further and further away from the planet Earth. So when we're addressing these issues for humans living and working throughout this entire journey, all the way to Mars and on the surface and then all the way back, we've really looked closely at how we're going to do these missions and what's going to be involved. I will tell you, with NASA missions, the number one thing we always talk about is safety. So we've actually looked into some of the issues that affect the safety of the astronauts on the flying in space. In the microgravity of space, hot air doesn't rise. You think, okay, well, that makes sense. But guess what? That really affects a lot of things, to include fire. How does a fire happen? How does it propagate? What does it even look like in space? Believe it or not, we've been studying this for years. We started some of the early experiments with fire on the space labs inside the payload bay of the space shuttle, and have continued this for many, many years on the International Space Station. So this just shows you very quickly the different shapes when hot air doesn't rise. And we've also used these cargo modules. You just saw the launch of the Cygnus cargo module. Several previous Cygnus cargo modules have included a spacecraft fire safety experiment called Sapphire, so that after we unberth the cargo module and are going to send it down into a deorbit that's going to cause it to break up and burn up, we actually set on fire, on purpose, different materials so that we can study how that fire propagates, and lots of sensors and cameras on board to take a look at that. Another thing that has to do with safety is we're in an enclosed environment, and we have to worry about the propagation of viruses and just toxic environments. Of course, fire would cause a toxic environment. But just delivered to the International Space Station this morning was something called ECAMSat, which is looking at E. coli bacteria that might be antibiotic resistant. What happens if we get that in a closed environment when we're going all the way to Mars? We've got to know how that bacteria is going to react in, and how we can mitigate that risk as we go all the way to Mars in an enclosed environment. Other than safety, we also look at life support. Life support systems are pretty important. We need oxygen to breathe and water to drink. So on board the International Space Station for many years now, we've had the oxygen generation system and the water recovery system. These are pretty efficient systems, but they're not 100% closed systems yet, so we're working on those efficiencies. Currently, the oxygen on the International Space Station, we recover about 42% of the oxygen on the International Space Station. We'd like to bump that percentage up to about 75%, with, of course, a full goal of getting as close to a closed system as we can. And when I say closed system, it means at different points we lose some of that, which means we have to replenish it at some point. Right now, we can send these cargo modules up to the International Space Station, and we can carry extra oxygen or water and replenish that supply. But if we're going all the way to Mars, we're going to have a much, much different plan for that. So what about food? That's always something on people's mind. The International Space Station just this morning received the Cygnus cargo module, and on board was some food for the crew, to include some special treats. We have Italian astronaut Paolo Nespoli on board, and we sent him some pizza. He'll be happy for that. We have been growing vegetables, or well, just growing plants in general on the International Space Station for quite some time. And one of these pictures here, you actually do see Scott Kelly, who you will see in the show tomorrow night, Beyond a Year in Space. He's actually sampling some lettuce with his crewmates, and this was 2 years ago. And now you see the other plants here. We have a more advanced system, and we've been able to grow 3 different types of lettuce on board. So the crew's been recently harvesting that and enjoying that. And you can imagine this is a very, very important capability to have as we travel further and further away from the earth and further away from your nearest grocery store or convenience store. So operations, just normal things like trying to repair something or just operating some equipment when we're all the way out at the surface of Mars is going to have to be a lot different. Nowadays, we just kind of pick up the mic, or rather just float over to the mic, call mission control, and have a conversation. But with these great distances, we're going to have potentially up to a 20-minute delay in the communications. So that's going to change a lot of the way we do operations. We are going to have to do a lot more work ourselves as astronauts. And again, we can't just jump in the car and go to the closest hardware store. So what you're seeing here is the in-space manufacturing. That white device there is actually a little ratchet wrench that was made on a 3D printer or additive printing. The concept is making your own tools or possibly even your own spare parts so that you don't have to carry all of them with you because, like I said, you can't just call up or just jump in the car and run down to the hardware store. The habitation structure you see is an expandable structure, just trying to advance that technology, again, for use on these missions as we go further out. And the next generation solar arrays is a new type of material that's going to be more efficient, as well as a new type of deployment mechanism. As I mentioned, with that distance all the way to Mars, there's going to be delays in the communications. It's going to be really, really important that we have efficient communications and very tolerant to different interference from space-type radiation. So we're looking heavily at laser communications, sometimes also known as optical communications. Just arriving on the Cygnus module this morning at the International Space Station was something called the OCSD, which is the Optical Communications and Sensor Demonstration. That's going to be actually on a CubeSat, a smaller satellite. So right at the end of the time that the Cygnus cargo module is going to be at the International Space Station, once it unberths and starts to move away from the space station, it will deploy this satellite, and we'll be able to test some of the laser communications between this CubeSat and the ground. And that'll happen in December. So again, stay tuned to some of the NASA social media. To continue on to the other types of science that we're performing on the International Space Station, we look heavily at the impact on humans and life forms in general. And here we just see some different pictures. We have heart cells. We've actually looked at the individual cells to see how they're performing in the microgravity of space. And we've actually got a DNA sequencer on board that we can actually study potentially types of illnesses and diagnose things on board the International Space Station. The effects on human health and performance is very important to us. So much so that we've had for many, many years in place something called the Human Research Program on the International Space Station. The Human Research Program looks at specific areas of concern for humans who are traveling in space. The first is radiation. Obviously, as we move further away from the Earth, we're exposed to the radiation of space. Isolation. As we get closer to Mars and start to have the delays in the communications, it's going to be a lot harder for us to have the communication that we currently have with our families. You'll be able to see on some of the movies and the things about the year in space with Scott Kelly that he could actually email his family, can pick up the phone and internet protocol and make phone calls, and even have video with his family occasionally. That's going to be a lot harder as we get further out, and you might actually start to feel isolated. And again, just the distance that we are away from the Earth, the further distance is an issue for humans on behavior and psychological type of problems. The comms delays, again, will reduce the number of contacts. We also look at the effect of gravity, altered gravity we call it, because we start here, we're all born and raised one gravity, we're used to that, but we travel into space, we feel microgravity, and then we get to Mars and we feel a different amount of gravity. So we have to make those transitions. We have exercise protocols on the International Space Station that help us combat the microgravity effect of causing bone and muscle mass loss. So we're looking closely at that. And then finally, just the environment that we're in. Okay, it's pretty harsh. The International Space Station is traveling around the Earth at 17,500 miles per hour. It takes 90 minutes to go all the way around the Earth. Half of that time's in the daylight, half of the time's in the dark. Light, dark, light, dark. You know, you got to get used to that. It's hot in the light, it's cold in the dark. And when you get to Mars, you possibly have toxic dust. And again, that closed environment that you could potentially get some microbial type issues going around. So this is a big deal, the Human Research Program. And so much so that NASA has 200 researchers across 30 different states and even partners internationally that are helping us to conduct all of these studies currently on the International Space Station. Speaking of studies on the International Space Station, how about a whole year in space? So the cool thing here is there's actually 2 investigations going on here. We have an entire year of Scott Kelly and Misha Kornienko, where we looked at these 2 men who spent a whole year in space and what was similar, what similar changes did they have that the 2 of them that spent the same amount of time in space experienced. But then we had the twins study where you have Scott and Mark Kelly, identical twins, and then we can look at the deltas, the differences between the twin who stayed on the ground and the twin who flew in space for an entire year. A very, very unique opportunity, and we are going to be examining that data and that science for years to come. So it's pretty hard to fly in space, and especially very, very challenging to get all the way to Mars. But I'll tell you what, I think a lot of people want to go. Anybody in this room, would you like to go to Mars? Yes. Good. Well, it turns out, I see a lot of people that are raising their hands. Thank you. It turns out we are not at a lack for volunteers for people that want to fly in space. Recently, we had advertised that we were hiring a new class at NASA. We had 18,300 applications. 18,300 applications. We had to go through all these applications. Oh, it took a long time. But the best news was these are the 12 people that were selected. They started training back here in August at the Johnson Space Center in Houston, Texas. And they are phenomenal people. I encourage you to go online and take a look at their biographies, and you will be amazed. These are the people that are going to help us develop these systems and fly these systems to get us further and further into human space exploration. So as I asked if anybody wants to fly in space and fly to Mars, if you got to Mars, this might be what you see. But eventually, you might want to come home, and if you're standing on the surface of the Mars, the Earth is there. You see it? Here, I'll give you a little help. If you're standing on the surface of Mars, this is actually a real picture from one of the rovers. That's what the Earth looks like from Mars. It's a long way. So we do want to ensure a safe return, and that's going to be challenging in itself. Just as a bit of trivia, we experienced the moon. We went to the moon 3 days, right? We were able to get off that surface and come back, but the moon's gravity was about 1/6 of that of the Earth. Mars gravity is 1/3 of that of the Earth. So it's a little tougher, and we need roughly, for every about 1 kilogram of mass to get off the surface of Mars, we're going to need about 7 kilograms of propellant. So it's going to be a little bit of a challenge. Maybe our next speaker will tell us something about that. We'll see. But actually, maybe some of you have some great ideas on how to help us out solving some of these issues and problems. Bottom line, the journey to Mars is filled with challenges. But we at NASA and with our NASA team and our partners, we are actively developing technologies through our ongoing research on the International Space Station and across our entire planet, right here on the surface. With all these teams, we are actively addressing the research and developing technologies to help us answer these riddles and to get us to Mars and further into human space exploration. And undoubtedly, as we develop these technologies, we're going to be able to apply some of these technologies to improving life right here on Earth. So thank you so much for your attention and for your interest in human research and space exploration.